Okay, thank you. So Nalini asked me to talk about the history of the IETF and kind of introduce you to the IETF. I do qualify as an old fart in the IETF, so I wore my official old fart T-shirt from IETF 15, 1989. Been around a little while, and that's how you know where the bodies are buried. It'd be around a little while. Let me start out actually with kind of a decade-by-decade view of how the Internet itself started. It started in 1962 or 1961, depending on who you look at, with a professor by the name of Licklider and his student, a fellow by the name of Len Kleinrock. And Licklider published we'd call it a blog today, published a paper in which he said, you know, wouldn't it be really nice if we could walk up to a computer and discover on that computer all of the information in the world. Now, understand that when he talked about a computer, he was thinking of something that looked like that picture. It wasn't a laptop, it wasn't a telephone, it was a room full of equipment. And it was, by the way, a lot smaller than the ones we use today. That particular computer probably had 32K 36-bit words, as opposed to the gigabytes that you find on your telephone or find, you know, on a laptop. At that time, what we experienced today was science fiction. I include a picture from, this is actually, I think, Star Trek IV. Scotty and a few other guys from the USS Enterprise go back in time, and they have to go save a whale. And Scotty finds himself talking to a 1990 Macintosh. And of course, in Star Trek, when you want to talk to the computer, you say computer, and then you talk to it. And so he figures it's going to be the same way. He picks up the mouse and starts talking into the mouse. And all the people from 1990 are looking at him like, you are crazy. Why? Well, you don't talk to a computer. Well, we talk to a computer today, you know. And what we're finding is that the industry is outstripping science fiction. Science fiction is now trailing behind what's really happening, which is a huge change. Science fiction used to be out in front. So I'm kind of interested to see what happens with science fiction. But for the Internet, it started with this guy Licklider saying, wouldn't it be nice to be able to go up to a computer and find all the information in the world? I think if he saw the World Wide Web, he would recognize it. So then they started working on that at UCLA and at Stanford Research Institute, what we now call Science Research International, SRI. And one of the people that was involved in that was a fellow by the name of Steve Crocker. If you follow ICANN or ICANN circles, Steve just finished being the chairman of the board of ICANN for 7 years. So he's very much involved today. But he sat down and he wrote a document and printed it out on paper and mailed it to his friends and said, you know, we need to have a way to exchange notes. And so let's create a document series. And to keep it low, to keep it under radar, to make sure that nobody thinks this is the standards for the wave of the future that will take over all of communications by 2000. He said, let's call it a request for comments. So he wrote RFC 1. Vendors in the 1990s started calling them requirements for compliance because that's what they were. Okay, now Bob Kahn and Vince Cerf were the two guys that developed TCP, or what we now call TCP. And Bob Kahn gave a talk in 1973 in which he laid out some fundamental principles of the Internet, and these principles remain true today. But he was talking about the network, the ARPANET at the time, which he imagined to be a network core surrounded by other networks that it would connect. And there would be four things that would be true about this network. One of them was that each of the connected networks had to stand on its own. The ARPANET wasn't going to tell it how to run its network, which is different than the telephone system. In the telephone system, they all work the same way. And they interconnect using very standard protocols. There was a big argument at the time between X25, which was a reliable protocol, and this upstart concept called MCP at the time, but IP, where you would send packets and basically hand packets to your enemy and hope that they arrived. Trust your enemy to do good things to your packets, and which is very much the way it works in the internet. Okay, so they described the internet as best effort, a network that would bend, fold, spindle, and mutilate packets and do anything that it wanted to. Might duplicate them, might drop them, might deliver them out of order. And they said that between these networks, there would be a black box. I don't know what's in it, but it works. And, you know, what today we call a router. At the time, it was called an Internet Message Processor, an AMP. And most horrible of all, from a government perspective, nobody could turn it off. There was nobody that was in control of it. Now, in India and in the United States, there are government agencies who have as part of their charter, should something bad happen in the country, they're in a position to take over the network and make it do what it needs to do. I actually spent a fair amount of time talking with the National Communication System in the U.S. They wanted to know how to take over the internet in the United States so that they could fulfill their charter. And, well, there is no central operational control. You can't do that. And that really bothered them. They thought that was a terrible idea. And then, now you've all heard that Al Gore invented the internet, right? How many of you have heard that Al Gore invented the internet? Okay, Al Gore didn't invent the internet. He did find money. And in the mid-1980s, what he had was 6 supercomputer centers that needed to be connected. He said, let's experiment with this, let's kick the tires, let's see what actually works. One of the networks that was put up was the 56 kilobit NSF net, and that became the internet as we know it today. Everybody wanted to connect to it, and it grew. So Al Gore basically found money, and the right thing happened. Now, a principle there that I think is important, which you're acting on today and tomorrow, but which is very important to the way things are developed, is that one needs to decide what needs to be built and then build it. Do a prototype, do a proof of concept, see what happens, discover that it's broken, fix that. This is an important part of the development of internet technology and has been for pretty much the life of the internet. What's the place of standards? Deciding what needs to be built. What's the place of open source, of prototyping, of hackathons, and so on and so forth? Taking that, turning it into reality, finding out what's broken, figuring out how to move forward. The two go hand in hand. Now let me talk for a few moments about the organizations of the internet. Here we're talking about the IETF. Turns out the IETF is just one of them. If I look at historic context, I pulled this picture out of a 1996 article by the guys who were involved in developing the internet in the first place. They went through a series of different organizations and renaming of one of the organizations, which was the graveyards of the internet. They called it the ICCC, they called it the IAB, as in the Internet Advisory Board. They called it the IAB, as in the Internet Activities Board. They called it the IAB, as in the Internet Architecture Board. It was always the IAB. But that essentially was the central organization, and the original developers of Internet concepts, and then they spun things off in order to facilitate the development of that. In the mid-1980s, which is when discussion of the IETF starts, the IAB was busily doing that and trying to facilitate development of Internet technologies, and it spun up 10 essentially board subcommittees, groups of those guys going off and doing things. One of them had to do with engineering, one had to do with architecture. If we look at those organizations today, the IAB is one of the set. That green area is this thing that we call the IETF. And then off to the side, we've got the research side, the IRTF. We've got policy, which comes from the IANA. And we have an educational and policy institution that the IETF can be under the charter of, which is the Internet Society. But all of these different things are involved. So 9 of the 10 task forces that were put together, the board subcommittees that were put together by the IAB, were eventually collapsed together, and they became research groups in what was called the IRTF and what is still called the IRTF. And understand that it's a multiple discipline organization, many different things going on in it, and pretty much autonomously. But it's also a multi-stakeholder group. It's it and the IETF are perhaps the first 2 multi-stakeholder groups. Now, at the time that they were created, we didn't have that word. They just were that, okay? But if you wander around in ICANN circles, you go to the IGF, you start talking around government, the term multi-stakeholder becomes very, very important, because what it means is that there's an opinion that is valid that is not the government's, and which is important to take into account. So the people that are working in the research task force come from basically all walks of Internet technology, including government, and are primarily the researchers working in those areas. With the IETF, we've got the same kind of thing. We've got a different set of disciplines, but it's a multidisciplinary organization, and it's a multi-stakeholder organization with people working in it from the operational community, people that actually operate networks, researchers, vendors, and academics. And we rub shoulders together. Why is that important? Because we all have something to contribute. And we often learn from each other, learn what the requirements are, learn what solutions might be possible, and how we might be able to proceed with that. Okay, so we've got a bunch of different sets of people and viewpoints happening with that. What are we trying to achieve? Well, we actually have a mission statement. The mission statement says we're trying to make the Internet better. And that, I think, is very fundamental. This Internet thing that we all use is not a perfect piece of technology. Believe it or not, there are changes that need to be made. And so we try to make that happen. We use open processes. And by open, I mean it's on the web. You can just go to it. As opposed to the ITU or the IEEE or just about any other standards development organization where certain things can be seen but others can't. We do everything out in the open. Now, how do we work? Well, we have a leadership group, the steering group, and that is composed of a bunch of people that we call area directors who try to charter the direction that their particular technology or technology area is going. We spoke a few minutes ago about the things that we're going to talk about today are IoT and security and SDN and I forget one other. So SDN is not an area, and IoT is not an area, but there are multiple working groups that address those things. Security is very definitely an area, and I forget what the other one was, but it was an area as well. So, these are the people who are basically trying to chart direction and make sure that the right people are in leadership positions to make things happen. What are our areas? Well, 3 of them are associated with layers. You look at the applications, looking at the transport layer, looking at IP itself and its connection to the underlying link layer protocols. And then 3 of them are cross-layer. Okay, so security, for example, we have operational security, we have encryption and signatures, we have a variety of different approaches to security, each of which is important in its place. And you'll find different working groups in different places that do that. And O&M, operations and management. One of the things that I did as IETF chair, way back when, we had a separate operations area and a separate management area, and they wouldn't talk to each other. The management people were theoretically making tools for the operators, and the operators hated them. And I decided they needed to talk to each other, so I shoved them together into one area. I'm not sure they talk with each other yet, but we do put them in a single area. And then, of course, the general thing, which is primarily a process. So what does an area director do? Well, he or she manages, and by the way, ladies, yes, I said she. We do have women that are very much involved in leadership in a variety of different capacities. In fact, one of our security area directors is just stepping down, and that's Kathleen Moriarty. So, I want to point that at you and invite you to get involved. Ladies are important too. Okay, so area directors are managing processes in an area, making sure they have the right working groups and working on the right technologies. Now, working groups are the place where most of what happens in the IETF actually happens. We have about 120 of them at any given time, and it's where the discussion of any given topic usually happens. Prior to putting up a working group, we have what we call a birds of a feather session. The English language phrase, or the English phrase is that birds of a feather flock together. If you all want to go talk about something, why don't you go find a bar and go talk about it? And that often becomes a working group, or is kind of the process for starting a working group. Now, a week and a half ago, I was talking with a guy from Bangladesh, and I wound up spending a few days earlier this week in Bangladesh. This professor told me, I want to give my students an assignment. I want them to go read an RFC, come back and give me a book report on the RFC, and then I will give them credit. That goes toward their grade, that they actually read an RFC. And I shook my head and said, no, you're missing it. RFC is the end of the process. If they want to contribute to the IETF, which is what he was talking about, how do I get people to be part of the IETF community and contribute? It's going to be about internet drafts. And let me say the same to you. RFCs are interesting. They're what you implement after the fact. But in the IETF, we discuss discussion documents, and those are internet drafts. So you'll want to be being familiar with and following and commenting on internet drafts. But let's talk for a minute about RFCs. Now, you remember where they started out. Steve Crocker in 1969 said, let's have a series of documents that we can exchange with each other, and we'll stay under radar. We'll make sure nobody notices we're here. We'll just call them a request for comments. So a request for comments today, an RFC, is an archival document. It doesn't change. Once it's published, it doesn't change. It's not usually a discussion document unless we want to change it, and we will change it by issuing a new RFC. Okay? So it's important for implementation of technologies, but it's an archival document. It's the end of the process from an IETF perspective. They fall in a couple of categories. One of them is procedure documents or like, in which we say this needs to be true. And we might change our minds and say something else needs to be true. But right now, we believe that this needs to be true. We call those a best current practice. So an example of a best current practice is BCP 38, which says that an ISP, when it's receiving packets from a subscriber, from a customer, should verify the source address on the packets and make sure that the customer is supposed to be sending packets using that source address, and if not, throw them away, because they're probably involved in a reflection attack or an amplification attack of some kind. The protocol documents are what we call standards track, and that is now 2 phases. There used to be 3, it's now 2 phases. We basically put a document up and we say, we think this works. We've tried it out, we've prototyped it, we've got it working in some isolated environment, and we think this works. And so we put it up and we encourage people to implement it, to deploy it, and then to comment back on it. And what happens next, if we decide we like it and it becomes important, then we might say, we're not going to change this anymore, and it becomes internet standard. Okay? Now understand that most of the internet works on proposed standards, not on internet standards. Most of the internet works on proposed standards. So at the time that we put this up, we're actually pretty sure that it works. But you know, so we have those 2 things. About 1 RFC in 7 is a standard. Most of the rest of them are something else. They are historical documents. You know, we used to do it this way, but now we do it that way. Or experimental documents where somebody's saying, you know, I'm trying this out. If you want to join my experiment, contact me, but here's what you need to think about. Or informational documents. Quite a number of the RFCs are informational. To give you an idea what kinds of things you find in informational documents, well, in 1985, a fellow by the name of John Nagel was looking at his network. At the time, he worked at Philco of Ford. He later became a professor at Stanford, and he's now retired. But routers at the time were very small and had very limited memory. And the reason for that had to do with the cost of memory. And anytime there was any kind of a problem, people would say, well, wouldn't it be nice if we could put actual memory into the routers and they would have enough to do whatever it was that they needed to do. And so he got to thinking about that one day and said, okay, let's thought experiment. What happens if I have a router that has infinite memory? And realized that there would be a problem with that the way IP was specified at the time, that it could actually create a situation in which packets backed up in a queue behind a link, and the link became fully utilized, but because of the behavior of the time-to-live field, which at that time was measured in seconds, packets would get to the other side and then be discarded as too old. And as a result, I could have a line that had 100% utilization and 0 throughput. He called that congestive collapse. We observed that in the NSF net in 1986 and 1987. He then threw out an idea, and it was a half-baked idea. He said, what if we sort the packets by source address and just run round robin among the source addresses and make sure everyone gets a turn in the barrel? that became the entire quality of service discussion, which you'll find in a variety of RFCs, the integrated services architecture, the differentiated services architecture, a number of research papers in various journals, and so on and so forth. Very seminal document. Okay, that's an informational RFC. What do you find in informational RFCs? People thinking about problems, problem statements, and architectures, and trying to describe what they have going on. Either that or poetry. Twas the night before startup and all through the net. Yes, we have poetry in the RFC series. And April Fool's jokes. Now, I don't know if you do this here in India, but in the United States, anything that you see that's dated April 1st is a joke. And we do. So we talk about IP on avian carriers. What IP on avian carriers, the way that works is you write the IP packet on a long strip of paper, wrap it around the leg of a pigeon, and throw the pigeon in the air. Okay, we have jokes in the RFC series. And we have documents that are historical, where we said, let's not do this anymore. Okay, so RFCs don't think of them as standards. Think of them as community memory. What we're doing in the RFC series is leaving breadcrumbs so we can remember where we've been and what we tried, what didn't work, and what did work, and why, and what it was we were trying to do. Okay. So now, having talked about RFCs, which are an archival document, they're the end of the process, let's talk a little bit about Internet drafts. The Internet draft is a discussion document. And there's probably 10 Internet drafts for every RFC that gets published, because they go through versions, people propose ideas, they discuss them, they decide they're done with them, they move on to something else. Internet drafts are a very active discussion thing, and at any given time, there's probably 2,000 Internet drafts that are posted somewhere and in discussion in some working group, or perhaps just in the general community. And you can look at these two sites and find them. The data tracker tells you the status of the document, and the tools site gives you the actual text of the document and the ability to do a diff against a previous version, the history of that document, and so on. The names turn out to be important. They tell you something important about the document. We have a variation in which people simply post a document that they want to talk about. They don't know where it's going to be discussed. That's not important to them at the time. So I included an example. Russ White is talking about an architecture for data centers that he calls Open Fabric. That might wind up in a working group. It might not. He's not describing where that needs to go, but it's a document that's put in for general discussion. Now, if I want to take a document and submit it to a working group, which is how documents get into working groups, then I would do the second kind of a thing. And in this, we've got Warren Kamari putting a document into DNS operations and saying, I would like to talk about a topic of having multiple responses in a single message, DNS message. Okay, so individual submissions is how you get Internet drafts into a working group. And then, of course, there's working group documents where we as a working group say, we want to work on this. This is something we'd like to refine and then turn into an RFC. For you, there are several ways to be involved in the discussion. And one, very obviously, is to attend IETF meetings. That's the expensive way. You can do the same thing from here, and I have people that are doing it in my working group. Simply being on the mailing list and joining by video conference or by Jabber or other things. It's easier to be there in person, and it facilitates getting work done, but you can do it remotely, and that means you don't have to spend an arm and a leg to get there, okay? So there are a variety of different mailing lists, including working group mailing lists, but also lists across the IETF on various topics. Why do I go to meetings? And yes, my first meeting was in June 1989. I've been to every meeting since, with the exception of the one in Seoul a year ago and the one in Carnegie Mellon in 1992. Okay, why do I go to meetings? Because it's useful. Okay, this is a community, and as a set of people, it's useful to know the people that are involved and to be able to talk by the water cooler, to go to dinner, to do things that build relationship and community. That's also important in the IETF. But when you go to a meeting, it's going to be 5 days of jam-packed stuff. So for me, this particular IETF meeting will start on Sunday. It will start at 9 in the morning and end at 10 at night. And then the actual meeting starts. It'll be a busy meeting for me. Everybody doesn't follow the same kind of tracks that I do, but that happens at meetings. Okay. Now, how do things get accomplished in the IETF? Well, it usually starts out with somebody asking a question or thinking about something or describing a protocol, which means that they write it down. And they usually write it down wrong. There's something they haven't thought of. There's something that doesn't work well with something else or whatever. And that will go into a working group and get discussed. And they'll need to change it. Okay? You can travel around that little loop for quite some time. I've seen drafts that had 30 and 40 revisions. Usually it's more like 4 or 5. But yeah. And then from there, if the working group agrees to it, it'll go off to the area director and ultimately to the ISG. In the ISG, what we've got is people from other communities. So let's imagine it's one in my working group, which is an operational working group dealing with IPv6 operations. When we send something to the ISG, I'm expecting the security people to come back and say, but there's an issue. I'm expecting the transport people to come back and say, but there's an issue. And so they go through that process. And they might very well say, could you please change this? Okay, they do that. And if they don't, then it comes out as an archival document, and it doesn't change after that. That's our basic process. That's what we do. So we decide what to build, and then build it. Okay, prototyping, early development, deployment in networks is an important part. We learn about whatever it is we're working about. And that eventually then results in what it is we're trying to do. So now let me throw this open for questions. Anybody have anything they want to tell me I did wrong? Okay, not seeing any. Back to you.